people started discussing about FHE for maybe maximum a year or less than a year. And basically it's because the need for privacy-based applications.
When we have a bit of privacy or a bit of confidentiality, what can we build that we couldn't build before? If you want to play poker online, you don't want your hand to be fully visible from the beginning, right? Like you have several stages where you want to only reveal your hand at the end of the game. In 2009, there was a massive breakthrough that allowed you to do any kind of operation on the encrypted data. Homomorphic encryption is really this ability that you can encrypt data, but you can still compute on it while it remains encrypted. The thing that makes this work in terms of composition is that all the data on the blockchain is encrypted under a single public key. We want to make cryptography accessible to the world without having a PhD.
Hello everyone, welcome to Just the Metrics podcast. Today we are having Morten Dahl from Zama as our guest. Zama is a company focusing on building privacy-based solution based on FHE, and Morten is the senior blockchain developer at Zama. So welcome to the conversation, Morten. How are you doing?
Thank you for having me here.
Great. FHE is very nascent technology. I think people started discussing about FHE for maybe maximum a year or less than a year. And basically it's because the need for privacy-based applications in both blockchain and AI area. Zama is a company that is building FHE-based solutions both for blockchains and for AI. And you are the senior chain director at Zama. So before we go into the details of the products, the mission of Zama, the products Zama is building, and what are the core reason why privacy is an important factor, could you tell us your story? How did you start building in this space? How did you end up building privacy-based solution for Zama?
Yeah, sure. I finished my degree in secure computation about 10 years ago. Since then, I went into industry and worked mostly with privacy-enhancing technologies in one form or another. That includes encrypted machine learning, federated learning, and some other privacy techniques, mostly around data. 2 years ago, I saw there was an opportunity to start working on bringing some of these privacy-enhancing technologies to blockchain, particularly around fully homomorphic encryption. Zama was founded in 2020 by Ran Hendy and Pascal Payet, and they've been working around machine learning and AI. Before I joined, they also started the division on blockchain. I was brought on as part of scaling that and growing the team working on blockchain. I think, as you said, we found a good need for blockchain as being transparent by design, but also having this need to have some confidentiality or privacy on-chain.
So why is confidentiality or privacy on-chain important for blockchains? Because as you said, it's built as a very transparent ledger where people can look into, and that's the way Bitcoin was invented, and then came Ethereum. And privacy was always seen as something bad from the regulator side or from the general public. But why is privacy important?
There is a difference between what we mean by privacy here. Transparency is also good. Transparency in goods in terms of figuring out what is the contract doing? What are you committing to by interacting with a smart contract? But it can also get in the way sometimes of saying, if I want to build an application, then do I want to reveal my balance to the entire world? Or do I want to have some kind of confidentiality around it? So I think there's two stories here. One is around, can we take something existing and add privacy to it? But there's also another story around, when we have a bit of privacy or a bit of confidentiality, what can we build that we couldn't build before? So does that open up for new applications where people are feeling uncomfortable building that today or using that today because of the inherent privacy or transparency on blockchain? I don't think it's about making everything private or trying to hide things, but simply saying we want to bring more about what you get in the classical world in a decentralized fashion. If you're a big bank and you would like to offer your services on-chain, maybe not all your customers are ready to go fully transparent, and they would like to keep some confidentiality. By adding this on-chain, we can open up new opportunities for people to move to a decentralized setting.
Okay. In that sense, what more capabilities, what more use cases that privacy can bring on blockchains that is totally absent right now? Could you talk about that?
So one could be like a simple thing as an ERC20 token, where you don't necessarily want to reveal your balance. You would still like to have a decentralized log of everything that happened and the security of making the transactions, but you don't necessarily want to reveal your balance. We're also seeing use cases around similar things like blind auction, where you can keep everything truly blind instead of having to reveal your bits. We're seeing use cases around distributed identity, where you want to put your credentials online or on-chain, sorry, but you don't want to reveal all of it. You just want to assert certain properties about this, that you're above a certain age, or so on and so on. So those are some of the use cases that we're pursuing now. There's also another category which is more around online gaming, where inherently you want a bit of, if you want to play poker online, you don't want your hand to be fully visible from the beginning, right? Like you have several stages where you want to only reveal your hand at the end of the game. So those are some of the things that we're seeing, and also that some of our partners are building applications.
Okay. From a technological perspective, the way I understand it, there are like a couple of technologies that enable privacy on chain, like CK, FHE, and in some cases, multi-party computation also. And Zama as a company is mostly focusing on FHE-based solution, the way I understand it. And FHE is like a very new technology. So a lot of people does not really understand it. So for a layman, like someone who wants to understand what FHE is, but does not have the technical background to go into the very deep details, what is FHE?
Yeah, so actually, it's been around since at least 99, and also earlier there are some schemes, but I think that the really important scheme came out in 99, and then that's what we call the partially homomorphic encryption, which is where you could do certain operations on encrypted data, but not every operation. And then in 2009, there was a massive breakthrough that allowed you to do any kind of operation on the ciphertext, on the encrypted data. And then later, there's been other schemes that are also what we call fully homomorphic, where you can do operations on the encrypted data. But basically, the idea is that you have a key like in normal encryption. So think of it as TLS or AES, and so on, where you encrypt the data under. And then the difference between homomorphic encryption and classical encryption is that in homomorphic encryption, you can operate the data while it remains encrypted, but without decrypting it. So a classical scenario would be that I, as a client, I have some data, and I want to run this through a service. I'm going to send this to a server that will, maybe you can think of it as one of the interesting use cases today, right, is that for AI and machine learning, we're sending a lot of data to a cloud somewhere that will then run it through the machine learning model and give us a result back. And one use case would be that as a client, you can encrypt your data, you can send it encrypted to the server. The server can still run it through the model, operate using these homomorphic operations, and arriving at an encrypted result that can be sent back to the client, who can then finally decrypt it. But that doesn't reveal anything about the client's input to the computation. So in other words, homomorphic encryption is really this ability that you can encrypt data, but you can still compute on it while it remains encrypted. And then only whoever has the corresponding decryption key can encrypt not necessarily or typically only the result of the computation, and not the inputs or the intermediate values and so on.
Oh yeah, so when you do the computation on the data, you are doing computation on the encrypted data. That means the true data is not revealed while the computation is being done. That helps to preserve the privacy.
Exactly. So I think you mentioned CK before as well, and zero knowledge, which is a good privacy tool. We think those two technologies are really complementary to each other. CK is about a typical use case today, right, would be to prove that you did a computation correctly. But the computation has to be done on plain text data. Some entity has to do the actual computation on plain text data and then prove, okay, here are the results, which may be delivered in the form of commitments or encryptions, together with a proof that we actually arrived at these results in the correct fashion. But the computation has to happen on plain text data. FHE, on the other hand, is saying, we can do the computation on encrypted data. We don't need to see the plaintext data in order to do the computation. So we can arrive at this. But FHE on its own doesn't tell you anything about whether the computation was done correctly. So one way you can get kind of the best of both worlds is that you can do the computation using FHE without revealing anything. And then you can use CK to prove that you actually did the computation correctly on the encrypted data. And then you get something that's verifiable computation that we're also working on. But we really see the two as complementary. I think in the context of blockchain, one interesting use case is CK is good if there's a clear entity that can hold on to the plaintext data. So if it's your data, your account and so on, you can keep a copy of the plaintext data and then just push commitments on chain and then prove that you updated these commitments correctly according to your private data. But if you want to build an application where you're mixing data from different users, then it's no longer obvious who is going to do the plaintext computation. So think of a blind auction where you have multiple users providing bids, and then at the end of it, you want to see who had the highest bids or who won the item. it's not really clear who's going to compute who won this, right? Because if you're using CK, then someone would have to see all the bits in plain text to do the computation. If you mix in homomorphic encryption, then anyone could take the encrypted bits and compute who won the auction, and then only choose to reveal who the winner of the auction was. Correctly.
Oh, yeah. So you can combine both of these technologies to enable use cases that are available right now or solve problems that has been troubling the blockchain space for a while now. For example, I have heard that MEV is a big problem in the blockchain space. I was reading through the MiCA about the regulations of European regulations for blockchain and DeFi. MEV was seen as something like an unfair market exploitation from their perspective. I heard that FHE and some privacy solutions can be used to counter the MEV. Is it possible?
So in principle, yeah. And some people are, as you mentioned, looking into this using various techniques. In the realm of confidential computing, you have fully homomorphic encryption that we were talking about. You have things like MPC or multi-party computation. And you also have secure enclaves. And in some sense, they're all solving the same thing, but using different security assumptions and so on. And where fully homomorphic encryption has really advanced in the past few years in terms of operations that you can do and efficiency and so on, it is still, one bottleneck is still performance. So we're seeing some applications where this makes sense. It could be real-world tokenization, real-world asset tokenization, where maybe you're not doing that many transactions and the latency is okay. So in this case, fully homomorphic encryption might make sense. But in other situations where you have very low latency or there's very high throughput requirements, maybe fully homomorphic encryption is not there. Our prediction is that in 2025, we're going to see hardware acceleration that will bring fully homomorphic encryption up to speed to some of these other technologies. Yep. Then the benefit is that with FHE, you don't have to rely, for instance, in a secure enclave on the hardware manufacturer and the entire process around that, but can simply trust the mathematics and the implementation behind it. So to answer your question more directly, I think for MEV, FHE could be a solution, but it might not be the most efficient one right now. And you might want to see until we have hardware acceleration that can solve this.
Because the real-time like computation, because it's like computation really expensive. I heard that it is, I don't know, like how many times, like CK was also, the proof generation was really expensive and proving time is getting cheaper right now, but still the proof generation is still expensive compared to even CK. FHE is still very computationally expensive, the way I understand.
Yeah, it is. So you're definitely paying an overhead when you're using this.
Okay.
But again, so I think for the past, we see let me just see what the numbers are we're having here. But we're roughly expecting it to be with hardware support to be supportive of a lot of use cases by 25.
Oh yeah, cool. And what kind of solutions are you developing for blockchain-based applications? If Zama has a AI wing and a blockchain wing, from a blockchain's perspective, what are you developing?
So what we launched last year was what we call the FHE-EVM, Fully Homomorphic EVM. It's not inherently tied to the EVM. It could work for any kind of execution engine for a blockchain, but we chose to focus on the EVM for now. But it's essentially an extension of an EVM stack where you can now have encrypted data types in your smart contracts. So concretely, we have a Solidity library, which is just a normal Solidity library, meaning compile it on your normal compiler stack, that adds a few encrypted data types to your Solidity contracts. So if you're building an ERC20 token, you can choose to say that the balances are now encrypted integers. The library gives you certain operations for comparisons, additions, and all of that can be compiled using your normal Solidity compiler. But then when you want to execute this on the validator software, you need to use our FHEVM, which essentially is intercepting these homomorphic operations and then calling into a homomorphic library, TFHERS, for doing the heavy lifting of the actual homomorphic operations. So this we launched last year. We have partners that have launched their layer ones using this technology. We also have some of the future projects we have is how do we enable this without making these modifications on the validator side of the software.
So FHEVM. So EVM is basically an execution environment that has a global state, which also allows full atomic composability between all the applications, because a contract would be able to call another contract. So when you say FHEVM, the whole global state is like the interactions are confidential, like the whole activity is confidential. The computation is being done on encrypted global state data, but the contracts will be able to call each other. So could you break it down a bit?
Yeah, sure. So we didn't want to be too opinionated about this. We wanted to give developers a lot of flexibility. And this is kind of the whole one of our visions, right? That we want to make cryptography accessible to the world without having a PhD in cryptography. So this was also something that's very important to us for on the blockchain side of things, where we're saying that as a smart contract developer, you just get new data types. So if you want to have some of your smart contract using plain text data and the other part using encrypted data, you're free to do that. We don't want to dictate how you do that. So if you're writing an ERC-20 contract and you say, okay, your balance is an EUINT, it's an encrypted data, then those ciphertexts will live on-chain. And whenever you use them, you will do the homomorphic operations. The EVM will do the homomorphic operations on this. If you want to have on the same EVM, if you want to have smart contracts using purely plain text data, you can do that as well. If you want to have your blind auction working on encrypted bits, use an encrypted ERC-20 contract using encrypted balances, then you can do that as well. The thing that makes this work in terms of composition is that all the data on the blockchain is encrypted under a single public key. So when we designed this, that there's a few options. One option could be that we say every user has their own encryption key. The problem with that is then if we want to do a blind auction, you're going to have ciphertexts that are now encrypted under different public keys. And that means it's not really easy to mix these ciphertexts into one ciphertext. You could do this, but this might require that users would have to come back and be part of the decryption process. And we would like to have a system where the users can give that bit. And then even if the users don't come back, if they drop out, we can still decrypt the final result. So for that perspective, from a usability side, we said it's not worth having a key per user. We would like this composition between different users to work on. Then you could also say, okay, we're going to have one key per smart contract. But then you also lose this composition between the blind auction using an existing ERC-20 and so on. So we also said, okay, between contracts, we also want to use the same key. And that means you're free to mix data between users or between smart contracts. The downside of this is that since we now have one global public key, there's also one global corresponding private key that allows you to do decryptions. So another solution we're building besides the FHEVM is what we call the KMS, or the key management system, where you basically have a service for storing the private key. In order to protect that, you could imagine several incarnations. We looked at using hardware security modules, but the one that we're more confident with is using threshold protocols. So the same way you can do it for signatures and so on, we can secret share the private decryption key. We can share it across a number of parties. And then whenever the system or the blockchain decides that here we should be a decryption, now it's time to decrypt the result of the auction, then you invoke the KMS and we run the threshold protocols between the parties, and then you get the decryption back. So those are the two things that are kind of needed for these encrypted smart contracts to work.
Oh, yeah. So people will be still able to do coding in Solidity.
From a developer perspective, you can keep using Remix, you can keep using Solidity as is. The only thing you need to do is import our library. It's a standard library available on Open7. It will give you a few extra data types, these encrypted data type, encrypted integers, encrypted booleans, and operations on those data types, comparison, and so on.
Okay. I think one of the reasons you are focusing right now on creating something like FHEVM is because EVM is the most adopted kind of virtual machine in the blockchain space. It has the most amount of users, developers, and in DeFi terms, TVL and everything. So do you think from your perspective, is EVM very FHE friendly? Do you imagine that there are some other kind of virtual machine that could be more friendly, or from your perspective, building this solution, could there be another solution where you can deploy this in a much easier way than EVM, or EVM from your perspective is good enough for what you're doing?
So we're not, one thing you could do is you could try to compile the homomorphic operations into EVM code and then run everything on the EVM, but that will give you terrible performance. So what we do, and one of the reasons that we have our own EVM or we patch an EVM, is that from the EVM's perspective, the homomorphic operations are essentially atomic. So concretely, we have a precompiled smart contracts that you have to ship when you want to use the FHEVM that offers the homomorphic operations. And then when you call this precompiled smart contract, we're calling into our TF-HERS library, our Rust library that implements all this. So in other words, it doesn't really matter on the EVM because every homomorphic operation is atomic and is being held or performed by an external library. So we get the same performance as if it was running on another platform and not EVM specific.
Okay. So from a layman perspective, is it right to call the FHEVM like a fully encrypted global state, a virtual machine with fully encrypted global state? Is it right to say that, or is it?
Yeah, you can say that. If anything, I just want to avoid the confusion that is not all the state that's encrypted, right? So smart contract developers, they get the choice. If they want to keep using plain text data in the smart contracts, they can do that. We have some examples online on GitHub if people are interested. In that example for the ERC20, the total balance, the total minted amount for the token is kept as a public value, and then it's only the balances that are encrypted. So it doesn't force you to encrypt everything. As a developer, you can choose exactly what it is you want to encrypt and what you want to keep as plain text.
Yeah, cool. And so I have recently seen that Zama has raised almost 73 million in a round. And Zama is a company focusing on AI and blockchain. AI is pretty understandable from an adoption perspective. We are in a place that we are seeing some AI-based consumer applications like ChatGPT start with. People can still imagine where this is going with AI. But from blockchain perspective, blockchain is still in the infrastructure phase, I guess. We haven't seen any big consumer applications coming from the blockchain side. It's mostly people buying Bitcoin and holding their wallet, and DeFi has a couple of million daily active users, but it dwarfs in comparison to some Web2 AI applications like ChatGPT. It has like under 100 billion monthly active users or something. So why is Zama also focusing on blockchain?
I think one benefit, as we talked about in the beginning, is of course that we see there's a big need for it. So this transparency by design is nice for some things, but it also could be a blocker for other applications to be developed. And we like the idea of allowing new applications to be developed on the blockchain, or moving more existing applications on chain, because we don't have this limitation anymore. So I think that's definitely a big motivator for it. On a more technical level, I also think the blockchain community, well, one is performance. So you can still do the computations that happens on chain are relatively simple. If you think of it as a token or a blind auction, or even as a distributed identity solution, the operations are relatively simple compared to running an input through, you mentioned ChatGPT or some of those models. The penalty that you get from, or the slowdown you get from encrypting the data is less noticeable the simpler the computation is. So that's another thing. Community around blockchain, let's say they may be more open to adapting new technology. They're more used to, okay, maybe it takes a second to do this computation because it has to be massively distributed or replicated and so on. So I think adapting the technology seems a bit easier in the blockchain space than in the other applications. We do expect that with hardware acceleration, that we will get significant speed ups in performance, and we will see more and more applications, both in AI or typical cloud applications, being suitable for starting to encrypt some of the data.
Okay. And data protection is also like, as of now, there is no data protection in the blockchain space, right? And a lot of applications require data protection, like companies or even private individuals, as you said. So like creating FHE-based solutions in the blockchain space could also result in blockchain-based solutions getting more and more adoption in that sense.
And we could see maybe some of the more traditional applications that are now kind of blocked to move on chain because of you're giving customers or clients might be used to more privacy, so they can't really move on to it. But as soon as you can offer some of the same properties that you get from a centralized solution, but in a decentralized fashion, we could imagine that more will be willing to move on chain for this. Some of the other applications we talk about or have seen is maybe data sharing. That if you want to, in the AI sense of it, if you want to allow your data to be used in a collaborative way, you don't want to just give your data away. Maybe you want to give it in an encrypted fashion and then only use for certain purposes.
Oh yeah. So are you collaborating with other entities in the blockchain space? What are the main partnerships?
So good question. So we're not actually building our own blockchain. So we're building the FHEVM, this engine to execute smart contracts that have this encrypted data in it. and then the KMS. But we're relying on partners to actually build a blockchain. So last year we launched, or Phoenix launched a layer 1 that's using our fhEVM in our library. We have Inco, we have Shiba that launched.
Oh, Shiba, the meme coin.
Yeah.
L1. Yeah, right.
So we partner with blockchain companies that want to build a blockchain around this, and we just the technology provider and the service provider for this.
Could you elaborate on these three projects that are leveraging FHE, like the solution built by Zama? Because I have heard about Inco and Phoenix, and also during the meme coin, I think the last couple of months, it's like the meme coin season in the blockchain space, all this. And I have heard that Shiba is also building layer 1 or layer 2 based upon the solution FHE stack. So could you give more insights on these solutions and this in terms of their focus? From your perspective, what are they building and why they are building?
Yeah. I mean, I think it's the same. So I think that they're trying out different applications for this. There's more general purpose projects they have, right, where they can invite various people coming. But one of the things we see is tokenization is a big one. Distributed identity. Gaming is another one they focus on. Let me see if I'm missing anything obvious here. Voting, of course, private transfers, equity, and so on, swaps.
Oh, yeah. And there was one take that I was reading an article that CK is really good for managing personal private state, and FHE is really good for managing shared private state. So from that perspective, FHE could be useful from a blockchain perspective, like a DeFi applications to private dark pool kind of DeFi application. Have you thought about that?
Yeah, so actually every quarter we run bounties at Zama where we put up a few applications that we think are interesting. We invite people to come and play with it or hack around with our technology. And that has been some of the applications we see as well that people develop solutions around.
Okay. Yeah. So apart from these new projects like Inco, Phoenix, and Shiba, other already established layer 1s or layer 2s that are using the FHE library or the FHE solution built by
so these are the first ones that are testnet and want to go to mainnet this year.
Okay. So you touched upon the hardware acceleration a bit. So could you explain like what do you mean by hardware acceleration? Because it has like how you think the efficiency gains would happen with hardware acceleration, but what exactly do you mean by hardware acceleration?
We're interested in two aspects there. One is right now most of the stuff is running on CPUs, but we also have a team working on running the stuff on GPUs. So the same way that that machine learning got accelerated by GPUs and then CK for that matter, this stuff can also be accelerated on GPUs. And then the other approach is more specific hardware, so FPGAs, ASICs, and so on, where you really tailor to a particular encryption scheme, and then you get the performance benefits from that.
Oh yeah. So what do you think would change compared to the situation right now in 2025, like 1.5, 2 years from now? What is the main change that's going to happen?
2 to 3 orders of magnitude of performance improvements. So.
Oh yeah. And is this because companies like NVIDIA are working on specialized chips for AI? Do you think AI is the main driver for this kind of movement?
I think we follow. So yeah, there are a handful, including some of the big companies that are working on specific chips for this. I think from there are some similarities with the CK hardware, especially specific hardware for CK, that share some of the same mathematics as FHE. So I think it's more in realm as opposed to AI.
Okay. Oh, yeah.
Some of the mathematics is a bit different. If we on, let's say, machine learning, you have a higher margin for error, for instance. That could be one technical difference. So you can use small rounding errors, doesn't matter that much. But we're less interested in this in the crypto space. Where we would like exact computations like in CK. Which also means that there are some, we can try to do this, but then we run into other technical complications where in the solution, we're not doing anything to interfere with consensus. So we can run on any consensus protocol. because our scheme is essentially deterministic, right? So if you have 10 validators or 10 full nodes, they run the computation, given the same ciphertext as input, they will produce exactly the same ciphertext as output. But as soon as you switch to floating points, this can deviate between some of the architectures. And for machine learning, this might be less of a purpose, but when you want to run a consensus on the bytes, on the results, then you run into an issue if they don't get exactly the same results there. So there are some interesting complications that I think doesn't exist in the AI space, but would also exist in the CK space.
Oh yeah, got it. So you work in a company where the main focus is blockchain and AI. Can you see some solutions, like situations where AI-based solutions can also leverage blockchain-based solutions? Is there some cross-section where these two solutions can be complementary to each other? Have you ever thought about that?
So some are interested in data collaboration, right? Where you can put your data into a data marketplace, and then it can be used for AI purposes or training purposes. A blockchain could be one way of realizing such a market. I think there's this idea that right now we if you want to have some assurance that the model was actually evaluated correctly, then blockchain could also be a way of doing this, where you send your prediction to the blockchain. You can test that, okay, it's there's a consensus around what the result of the prediction should be, and then it's sent back to you. So I could see some intersections here.
So from a big consumer application perspective, is there something more concrete that can come out of this, in a sense that what does not really exist right now? For example, I was thinking about it. AI would eventually result in a lot of deep fakes, a lot of content with AI. As the system gets more efficient, it gets hard to differentiate between AI-based contents and real contents. Do you see any application in that space where blockchains can be leveraged?
I mean, you can use it to track origin around it. I don't know if confidentiality, if it plays a part there.
Verifiability is so that's verifiable. So it's like some kind of verifiable computation, right? What FHE, CK, and everything is doing. It's like, yeah. So is there a place for any solution in that, like where you can leverage that?
I don't know if you would benefit where you would benefit from confidentiality in that process. There's been some work around having NFTs, and then when you buy the NFT, you get access to this confidential data. That's another solution where this could work. And I don't know how that could work in a data context, where if you own the NFT, then you can access the data set for training purposes and so on. But testing if the data is honestly generated or is not coming from a model.
You will need some kind of identity system that goes along with it to prove that, okay, this came from a human being. How would you eventually deal with situations like deepfakes, right?
So you could use something where you keep your credentials or your sensitive information encrypted on chain, and then you somehow prove that, okay, it was derived from this or it was computed from this. So if you want to see the origin, then you can point to something on chain where this is coming from. You could potentially do the same with CK, but again, it depends on how much is mixed, right? So if it's just your data, then you can keep the plain text copy, and you could prove this with a proof. But if it's coming from mixed data or mixed data sets, maybe this FHE would be a better solution.
Oh, yeah. I think that's cool. So like if developers want to learn more about what Zama is building, the solution Zama is building, how can they learn more about it? And, the main channels where they can look into these informations and the products.
Going on our website, Zama AI, would be a good start. There we have links to the GitHub repositories around the fhEVM. We have tutorials. There's a link to various workshops we've given where we go through how to build various smart contracts using the fhEVM, how to build your own, or how to integrate the fhEVM into your own stack. Most of the stuff we do is open source, including the fhEVM, so people can go play with it, experiment, spin up their own node, see how this is working. We have a small dev net we're operating, and then of course partners, they have their test net, soon to be mainnets, where you can also experiment with this. But I think a good place to start is Zama AI. There should be links both to the GitHub repositories, where we have examples, tutorials, the source code, And there's also a product page where you can read a bit more about what it is, and we have a collection of links. Kind of interesting.
Yeah. Cool. So I think we have covered FHE and what Zama is building, the products Zama is building, and all the projects that are leveraging it. Could you just talk about, in a broad manner, what these solutions could eventually enable, like in the next 5 to 10 years? If you can think about in a 5 to 10 year time frame, where are these technologies ultimately going?
We want to do at Zama as a company. So you said before, right, that for the applications, we're focusing on AI, machine learning, and then blockchain. But there is a third component, which is this fundamental library underneath, where we have, so as an example, we're around 75 people at Zama, and we're 15 in the blockchain team, and I think roughly the same in the machine learning. And the rest are working on the encryption scheme, on the research behind it, efficient implementation, and so on. So we are imagining other applications that will come that will use the same technology. And for FHE as a technology and Zama as a company, we would like to encrypt the internet. So one way of seeing it is that today, when you're interacting with, or encrypt the internet end to end, in the sense that today, if you go to a bank, your connection between your computer and the bank's computer, that is encrypted, right? And then when the data leaves your computer, it gets encrypted, so no one on the internet can see the data. But then when it arrives at the bank's computer, it's decrypted, and they process the data in plain text. What we can do is we can encrypt the data not only during the transition from your computer to the bank's computer, but also at the bank's computer. So you get to choose exactly what of your data that you reveal. They can, whatever the computation they need to do, they only have to see the result of this computation. They don't have to see the inputs to the computation. So it gives you much better control about how your data is used and what is revealed about it, as opposed to just giving everything. So it's really more fine-grained control around how your data is used and revealed.
And that is really important for full control of your data, but it is verifiable. So that is an ideal situation, that this is where this technology is moving in the 5 to 10 years time.
And I think both as a consumer or user of the system, you want to protect your data, but also in some applications, the consumer of the data would also say, I don't actually want to see all this data. Some of this data might be toxic for me to have. So if I can get your data and do the computation I need to do on the data, but revealing all this, then that will be good. One of my examples from earlier work was, you want to train a model on sensitive data in the medical field, healthcare field. And then what to do is you have to collect all this potentially very sensitive data. So, if there's a leakage of the data, this could be the end of the company, it could be a big scandal and so on. So you might be blocked in training this model in the first place because you don't want to have all this potentially toxic data. But if you had this data in encrypted form and you only learn the final result, then maybe you'll be more willing to take on this task. So it's not necessarily just about protecting the client at the end, but also about who wants to touch the data. You're running less of a risk by working on encrypted data.
Oh yeah, that's true. And in the medical field, data is very sensitive because my day job is in that field, and I really understand what kind of difference it could make if there was a technology that could enable dealing with that data without actually revealing that data. So this is a series about FHE with Zama, and I'm trying to bring on speakers from Inco and Phoenix and projects like that. Thank you so much for taking the time, Morten. It was a fantastic conversation about Zama, FHE, and the future of solutions that will be built on blockchain and AI. Thanks for tuning in. If you are keen on getting deeper insights about Web3 tech, our newsletter, Just the Metrics, is just what you need. It's packed with valuable information, and it's completely free. You can subscribe by clicking the link in the video description. It's a great way to keep up with the latest in the Web3 space straight to your inbox. And before you go, please hit that like button and don't forget to subscribe to our channel for more updates and insights. Your support is what keeps these videos coming. So see you in the next video.